Hi, Celia. I see you are already in the meeting. So this is just a technical test. I just asked you to unmute yourself. If you can hear me already, it would be very nice if you could unmute yourself and tell me
Hey.
if everything is okay and you can hear me well.
Yes, I can. Can you hear me?
Yes, it works perfectly fine. Celia, do you want to do any technical check? Do you want to maybe present your screen for a second or turn on your camera or whatever you want to do?
Sure. That would be great.
Yeah, okay, we can do that.
Hey
Let me
there.
quickly stop sharing from my PC. We still have a few minutes, so it's fine if we can use that. By the way, hi, welcome. I will welcome you
Hi.
officially a little bit later.
Thanks so much. Is this camera? Let me just check.
Yeah,
It's a little dark.
I
I'm
can
not sure
hear
why.
you good, and the video, your camera works perfectly fine.
Okay, cool.
Just let's try a quick sharing of the screen.
Right. I'm just closing out my other applications.
Uh-huh.
Cool. All right. Share the whole screen. Okay.
Yeah, that looks good. That looks really good. In Zoom, you can disable annotation of your shared content. I would recommend to do that. Normally, we don't have any problems, but at one point in time in a past meetup, we had one problem with a troll. So therefore, if you want, you can disable annotations. It's just as you like, just to make sure you can do that.
How do I disable annotations?
I will send you a link in Discord so you can see it, okay?
All
You
right.
can
Thank
only
you.
do that when you share something, so you have to do it after starting the sharing.
Okay.
But yeah, that's fine. But everything looks good. So I think I will share my opening slides again. And
Cool.
we have a few minutes until we get started. I will start with a few minutes of community news, introduction, and things like that. And after between 5 and 10 minutes, depends, I will ask you to unmute yourself and then we can get started. Is that okay?
Great. Sounds
Just
good.
a last question, then we are all set. Typically, I watch the Discord channel and so on. And if any questions come up where I feel that it is okay to ask because they are really relating to what you're currently saying, is it okay if I relay those questions to you? Or do you want
Sure.
to monitor Discord yourself?
You can relay them. That's fine.
Okay, then very good. Okay, see you in a few minutes.
Cool.
Hello and welcome to the 7th Rust Linz Meetup. My name is Rainer Stropek and I am very happy to be your host today for today's Rust Linz Meetup. Before we get started with the first talk of today, I would like to give you a short overview about what you can hear today. And I would like to present a bunch of community news, which might be interesting for you if you are interested in Rust, in programming in general, or if you live in the town of Linz, where we are broadcasting today from. First, the Rust Linz Meetup, let me tell you a little bit about it, because I've seen at meetup.com that some people have subscribed, have RSVP'd to this meetup who weren't here before. This meetup, the Rust Linz Meetup, is an event brought to you by a local coding club, the Coding Club Linz. We do a lot of community meetups, and we also do programming clubs for kids. I will tell you a little bit more in a few minutes. Our website, you have probably already seen it, but if not, here it is. It's rust-linz.at. You can read a lot here, and if you're interested what's coming up in the next meetups, always look at this page, and we will announce the speakers and topics here on this page. We want to be a beginner-friendly meetup. That is very important for us. So if you are interested in Rust and you are actively learning and you have some interesting content, independent of whether it is a deep dive or whether it is something which might be interesting for Rust beginners, then we definitely want to hear from you. So please use this green button here, submit talk in Sessionize, and don't hesitate. If you are new to speaking, if you haven't delivered so many talks already, that's absolutely not a problem. This is a meetup. We are all friends here, and we definitely want to hear from you. If you have an interesting finding, an interesting project, an interesting read about Rust, something where other people might also benefit from it, who are also learning about Rust. So let's talk about today's speakers. We have as our first guest speaker, and we would like to say a warm welcome to Celia Lewis. Celia will talk about getting started with open source Rust. And our second speaker today will be Will Hawkins. He will talk about how performance compares between range and counter-based loops in Rust. So we are really looking forward to your talks, Celia and William. And yeah, we wish you good luck, and we are looking forward to it. If you would like to chat with us, if you would like to ask questions, if you'd like to chat with fellow Rustaceans, please join our Discord server. Here you see the join link. You can just click on it. It's also posted on our website. It's also posted on the YouTube channel. Just click on this link, join our Discord server. And if you ask any questions through the Discord server, I will relay your questions to our speakers of today's meetup. Community news. We have, as always, a bunch of community news. First, our very own Coder Dojo Linz. Coder Dojo is a programming club for kids between 8 and 17, and our next online meeting will be tomorrow. As every Friday, we will do workshops for kids. We have workshops for very beginners, very young kids who have never written a line of code before, and we have also workshops for more experienced teenagers who already have a little bit of programming experience but who would like to dive deeper. We have, for instance, a special workshop tomorrow, again, a hacking workshop. So if you are curious about hacking, how you can check whether your system is secure, definitely take a look. The meetings are in German. They are online. So if you speak German, you can definitely attend wherever you are. You can join our Coder Dojo Linz meetups. The next one, our friends at the Female Coders Linz. The Female Coders is a community of girls and women who either work in informatics or who would like to get started there. Their next study group is on February the 17th. Please check out their website and definitely also check out their Meetup page. You will find all the necessary information about the content and about how to join on this URL. Female Coders Linz. Our friends from the Microsoft Power Platform. I know that's not so much Rust related, but we have a lot of friends who also do Power BI and Power Apps and things like that. They organize a summit, the Power Platform Bootcamp. It will be on the 19th of February. And if you are interested, just take a look at this link. If it's too fast for you and you don't have your phone here to take a picture, just ask a question on the Discord server. I will happily share this URL again with you through Discord. We have also a rather new meetup, a meetup that started right in the current Corona situation. Everything is online now. The Cloud Native Computing Meetup Linz. Their 5th meetup will be on the 23rd of February. I have forgotten the topic. I'm very sorry. Please take a look at the meetup page. You will find the speakers and the topics there. Stefan and I had the honor to present, to moderate a meetup at contributing.today on January the 27th. We, for instance, had Ryan Levick, Mr. Rust from Microsoft, in an Ask Me Anything session. And the videos are now available. So if you couldn't make it to this meetup, the Ask Me Anything with Ryan was really interesting. He talked a lot about how Microsoft is using Rust and about their latest projects, and therefore it might be worthwhile checking out the videos on Contributing Today. Here is the link, and feel free to take a look at these videos. It was a real honor to present this meetup, and it's a great series. Even if you're interested in other programming languages, like for instance, Go and Python and so on, they have very interesting videos there. Last but not least, we definitely want to say a big thank you to Microsoft. Microsoft is again sponsoring this meetup. They are helping us finding new and interesting speakers in the future, and they are also supporting this meetup financially. We say a big thank you to Microsoft, and we also would like to promote workshops from them. Their cloud platform, which is called Azure. If you haven't taken a look at it, you should definitely do that. And Microsoft Austria is offering Azure workshops. You can take a look at these workshops. The link is here. Again, if it's too fast and you have no chance to write that link down, then ask us on Discord. I will share the link again, and you can register for these workshops there. I think most of them are free, but you will find all the details in this URL here. And that was my introduction, and that was the community news. And with that, I think it is time to get started. Let me stop sharing my screen and let's ask Celia to unmute herself and enter the stage. Celia, you are our first guest speaker today, and we are very happy to have you. Hi, Celia, here you are. Thank you for visiting us here in the meetup. Where are you broadcasting from? Where are you located?
Yeah, so I'm in Boston, Massachusetts, US. Yeah, so a little bit far from Linz, but
a little bit far from Linz. Here it is late in the evening. It's already getting dark. For you, it's probably early in the morning, right?
Yeah, it's 11:30. So this is all sunlight. Yeah, it's crazy.
Okay, very good. We have a lot of snow here in Austria. Do you have snow too?
Oh yeah, we had like a foot the other day. It's snowing all over the place.
Awesome, awesome. Celia, I would ask you to share your screen so that we can see your material. We tested it before, so I'm very positive that it will definitely work.
I think it will work okay. Yeah.
Very good.
See that?
Yes, we can see it. Celia,
Great.
The stage is yours. We are looking forward to your content. I will now mute myself and stop my video. And if it's okay for you, I will relay any questions from the community to you. Okay?
Sure.
Good. Thank you very much. We are looking forward.
Great. So hey guys, my name's Celia, and I'm going to give you a little presentation on getting started with open source Rust, subtitled Get Good at Open Source with Embark Studio's Rust Ecosystem. So kind of a mouthful, and I'm sorry for the pun, but I had to. So the talk structure for today is we're going to go over, why open source? Why should you care about open source as a software engineer, as a hobbyist? What can open source do for you? After that, we're going to go through a quick demo that I made for this presentation, which kind of demonstrates an open source workflow using GitHub, including everything you would do using open source during the day, such as forking a repository, finding an issue to work on, using branches, editing on your local machine, and then finally pushing to GitHub and creating that pull request. And then during that demo, I'm going to highlight, how to be a PR superstar. So this is just how to create a really good pull request. And finally, we're going to end it off with going over a little bit about Embark's Rust ecosystem and how you can participate in it once you're an expert after this talk. So first up, what is a GitHub? I'm sure everyone here is, or most people are familiar with GitHub. And if not, you're not alone. I, a few years ago, had no idea what GitHub was. I had no idea what open source was in general. I was new to computer science, and everyone was telling me to get involved with like an open source project. They said, you got to put it in your resume. It's how you get a job. It's a great way to meet people. And it turns out they were right, but I had no idea where to start. So that's why I kind of wanted to make a presentation that I wish was there when I was first starting out. So why should you do open source? Well, I think it's really cool because you get to crack open the software that you use every day. I know most of us, we might use open source software every day, but a lot of us use software that isn't open source. And it's kind of a mystery what's going on, in the back end, how it's all working. And it's kind of amazing when you open up an open source project and you can see everything that's going on. You can see what issues they're working on, what small changes are being made. You yourself can work on something. You can crack into the community and start talking to people. So that's why being an open source contributor is so rewarding, is for these 4 points. You gain a deeper understanding of the technology. Sometimes it can be a technology you've never used before. Like if you've never touched Rust, joining a community working on a Rust project, you get to have that mentorship built in. You can contribute in a small or large way, which is awesome because you can just fix a few typos, which I know a lot of people love to do, or you can change the whole game and move a whole feature forward. Again, you can put in your resume. It's a great thing to start your software engineering career on, or any career in tech. And finally, you can make connections and find community. So a little bit about us. So I work at Embark Studios, which is a video game studio in Stockholm, Sweden, a little far from me in the US, but we're working on 2 games and also a game creation platform, which is the team that I'm on. And we are obsessed with Rust. It's our language of choice, totally. And we're really obsessed with creating a Rust ecosystem and a community around it, because we maintain a lot of open source Rust projects. And having people in that community and on our Discord and working with everyone to maximize what we can do at Embark is really important to us. So that's why I get to come here today and why I am just really happy that this role exists. So yeah, without further ado, let's get familiar. I'm sorry again, but we're going to work through a open source workflow using GitHub. The exercise that I did today is how we're going to go from an empty hard drive to literally having no experience using Git, just having it installed, and to actively contributing to this open source project. And as I said, there is one prerequisite, which is that you have to have Git installed if you want to follow along. Obviously, you can just watch the presentation and not do anything, but if you want to do, I'm going to link the repository later. So if you want to go back and try it yourself, you can do that, but you're going to need Git. That's it, just Git. So cool. Let's talk about the project. So it's an interesting one. So in this imaginary world I've created, there's this open source project called restaurant-rs. And what this project does is it basically allows restaurants who want to use an open source software to display what toppings they want to put on their pizzas. That's it. That's what this little software does. And our favorite restaurant has an open source ordering system using restaurant-rs. But they're running into a strange issue, which is that their toppings are all messed up. As you can see on the right, customers are ordering tire pizzas, and that just doesn't seem right, given that that's not a topping that they actually have at the restaurant. So we're going to check out this repository and see what's going on. Okay, so this is the restaurant-rs repository. If you're new to GitHub, I think this can be a little bit overwhelming at the beginning, but it shouldn't have to be. So really the main things you have to worry about are, here's our code right here, our issues tab, and then pull requests. As a contributor, especially as a, not a maintainer, these are really all the things you have to worry about. So if I'm this person who's completely new to open source and my friend told me, oh my God, this restaurant's having this big issue, the first thing I'm going to do is just go to the issues tab and check out the issue that my friend was talking about. Our chefs are running out of wheels in their cars. So I'm going to say off the bat, not the best issue title. This doesn't tell us a lot about what's actually going wrong in the system. It's more of just complaining about the restaurant, but we're going to touch on later how to make very clear and concise issue and PR titles, but let's dig in. So our friend Pizza Fan here works at a pizzeria, and they use restaurant-rs in their ordering system to display the available toppings to customers. So customers are ordering something called tire pizza, and they have no idea why. And his brother pointed out that the orders started pouring in after a recent PR was merged, altering the pizza.rs file. Maybe that's the issue here. So already, as an open source contributor, that points out to us, okay, the issue is probably in this, and the issue arose when a recent PR was merged. So someone altered the code in this file, and now there's a problem. So we'll know where to look when we start altering the code. So what else do we have here? We do not offer tire as a pizza topping. Okay, duh. And these are the toppings that should display. So we know what needs to be changed, which is that these are the toppings that should be displaying. Okay, easy enough, right? Okay, so as an open source contributor who's new to the thing, our first step is we have the issue down. Now we are going to fork it. So you go over here and we are going to fork it to our account, which I'm going to do my personal account. And what does forking do? It essentially just creates a copy of the core repository. It's just creating your own copy so that you can edit it and do your own thing. And then eventually when you're done changing your fixes, you can do the pull request to then merge your changes with the main. So we're going to go all over that again, but all you have to know is it's your own copy of the project. So now we have it. And what we're going to do next is open up PowerShell. Just going to make sure we can see PowerShell here. Great. So make it presentable. Okay. So once we're in PowerShell, what we're going to do is we're going to take the repository that's on GitHub and download it to our computer using Git. So we can edit it on our local machine. So the first thing we want to do is go to this code button here. And under HTTPS, we are going to copy the code using the clipboard and go back here and write git clone and then Control V to copy it in. Oh, actually, I made a mistake. We're not going to do that yet. It's good practice to make a new folder, obviously. So I'm going to call this Linz. And then I'm going to CD into Linz. How did you manage to get Git on Windows? So someone's asking on Discord. I'm going to include, actually in the slides, there is a link that you can just download Git. It's an easy install, so it should just take a few minutes. And then you can access it in the terminal like PowerShell. So in Linz, we are now going to do the command I was just talking about, git clone. Awesome. So we see that it is now cloned everything to Linz. If we use ls to see what's in the folder, we now see that our repository is in there. So we're going to cd into that, look at our folder again, and you'll see that all of the files that we just saw right here on GitHub are now on our computer. It's magic. Okay, so what's next? Well, now that we have everything downloaded, it's just time to edit. So what we're going to do is we're going to open Visual Studio using the code.keyword. Yep, you can still see that. Cool. Now let's check out what's happening. So as we saw in the issue, we saw that our problem was probably going to be in the pizza.rs file. So that's where we're going to head first. But it is important to check out what's happening in main. So this is a Rust program. So main is now incorporating the pizza library to run this function called available toppings. Okay, well, let's see what that actually does if we run it in PowerShell. So since this is Rust, it's super easy. We're just going to do cargo run. And here we are, we found our problem. So it's showing the available toppings are tire, 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 tire. Cool. And I see another Discord thing come in. I'll probably answer it at the end, but thank you for the message. So I think it's a pretty small code base. You can probably already see the problem, but we're going to go through each part really quickly. So in pizza.rs, we have an enum to start it with the toppings. And inside of toppings, there is a variant for each of the different toppings we want to order. Then there's going to be impl for toppings. And then under that, we're going to have a function called toString. And then finally, there's available toppings, which is the function that, as we know, was being called inside of main. So obviously, that's where our investigation should start, because that's what's going wrong. So what is available toppings doing? Well, what it's doing is storing inside of a variable each variant of the toppings enum. So we see for pepperoni, for sardines, for onions, each of them are being stored in a variable, T1, T2, etc. So right here, all it's doing is doing a print statement, available toppings, and then it is just printing each of these variables using the toString function that I've created here. So now you can probably make an educated guess what's happening. What it's doing is that no matter what the variant is, the match function is matching it to a string called tire. So this is a pretty easy fix. Let's just go in and make these correct. Hopefully I spell everything right, or else someone else is going to have to do a new PR and fix that, and then et cetera, et cetera. But cool. I'm going to hit Control Save. And then let's try cargo running this again. Great. So we see it's working now. Available toppings, pepperoni, sardines, onions, bacon. Fantastic. So we are halfway there. So we have now, again, forked the repository, cloned it to our computer so we can edit it locally. We fixed the issue. And now finally, we are going to put it back online so that we can create our pull request. So how do we do this? So this is where the git commands come in. So the first git command we're going to do is called git add, and then I'm going to do a star, which means everything. And I'll explain what that is here. So what git add does is you can think of what's happening as you're stuffing an envelope. So what the envelope is we're putting all the files that we just changed inside of this envelope. And then we're going to ship it off back to GitHub. So what git add does is you put the files in the envelope, and then we use git status to see what files are in the envelope. We can see that it is pizza.rs. And then the final command I like to think about is zipping the envelope, which is going to be git commit. And what git commit does is it just finalizes that package so it can be sent up. And one thing a commit does need is a message on it. So the message should say, what does this package contain? What does it do? And what this does is it fixes the entire issue. Awesome. And you can also do something, which is if you do git commit and then -a, you can skip this, and it's just a faster way to do it. But great, now we've added, we've committed, and it's finally time to push it up. So we just do git push. And there it goes. It is now being sent to GitHub. So if we refresh our fork, we will see that 26 seconds ago, it just received a package from my computer, and it has updated the source code. And you'll see the GitHub will display the message that we sent right here. So great. Now there's just one last step. I think you remember, it's creating the pull request. And GitHub is really handy because it will tell you right here that this branch is one commit ahead of Pizza Fan Master. And what that means is that since I've fixed the issue, since I've edited the code base, now my repository is further along than the core one. And in order to make the two equal, we have to create a pull request so that my repository can be merged back into the main one. So that's exactly what we're going to do. So I hit pull request, and now it gives you a screen where it handily shows you what's been removed, the deletions, and then what's been added. Awesome. So then finally, we're just going to hit create pull request. And here's the best screen ever. We're finally ready to type it up. So what I'm going to do is leave this very quickly to just go back to the presentation and talk about, oh, it'll load, writing a good PR. So how do you become a PR superstar? There's a few just very quick important parts, which is clarity. So you just want to be very clear about what issue you tackled and how you did it, but also be concise. They don't need to know every detail of how you fixed it. Someone who's looking at it from maybe a non-technical perspective, who's just the code maintainer, or there's so many different roles in open source, but not everyone wants to know exactly, what function did what, unless it's relevant to what you fixed. But sometimes you can just give a brief and semi-detailed review. And as I mentioned, relevance. If you are fixing one issue, you don't want to mention another issue in your PR because that can confuse the person who's reviewing it. So you just want it to be clear, concise, and relevant. So someone who's maintaining the project can quickly go, you know what, this solves the problem, let's merge it. And some very quick and relevant to GitHub tips for becoming a PR superstar. We want to keep the PR title under 65 characters. This avoids wrapping and the text being cut off. So you can easily see it in an email or however you're receiving it in your inbox. It just makes it easier for readability. And you can add the details in the body of the PR. So you don't have to have 18 different things happening in the subject. Next, super important, is link the issue that has been addressed. So if you've addressed, the tire issue, we're going to put that inside of the PR so that GitHub can know innately to close that issue once the thing has been merged. So you can use certain keywords to show GitHub that you have done this, which is fixes and resolves, and also a few others, I think. If the PR is unfinished, or someone gives you some feedback and they say, you know what, I think this needs a little bit more work. There's an error here, or there's something wrong here. You can convert it to something called a draft PR, which is exactly what it sounds like. It's just a PR that needs rework, so it won't be merged automatically. And then finally, the most important point, I think, is that short, impactful pull requests are almost always better than long and messy pull requests. So if there's a lot of issues in a repo and you look at a few and you're like, you know what, I can solve all of these. I'm a super cool expert software engineer. And you go into the code and you solve a bunch of things at once and you do a lot of great work and all of it works and it's awesome. And then you create a pull request and you type up everything you did. While that may be cool for you, someone who's coming at that knowing nothing of what you did, it's really hard for them to read all of that and make sure that you addressed every single issue as well as you can, because they can get lost in all the text. And this goes back to our other point where conciseness is really key. So the best thing you can do is, if you're going to address an issue, make a PR for that issue, and then a PR for the other issue, and a PR for the other issue, so that someone doesn't have to do all of this work at once and multiple people can address different PRs. So it's good for a lot of different people for a lot of different reasons. So short, impactful over long and messy. And then we're going to go back to the pull request and give it a better title, because fixes tire issue isn't the best. So I'm going to say makes available toppings function. And again, this probably isn't perfect either. I'm doing it on the spot, but you can always revise it later or clarify if someone has a question. Present the correct toppings. So we said fixes, then we're going to look at it. Our chefs are running out of wheels in their car. That is the issue. Fixes number 7 by changing the, and we can sometimes use a code block to reference a function. So I'm going to do available toppings function to correctly return the strings pepperoni, onions, bacon, what was the last one? And sardines. Previously, it was returning tire no matter what topping was chosen. Great. So this is super simple. Gets to the point. It fixes this issue by changing this function to correctly do this instead of what it was doing before. Awesome. So we're all set. We're going to create our pull request. Cool. So congratulations. You are now done. I mean, I guess I did it, but if you followed this all the way through, you went from having no experience using GitHub, using Git, to fixing an issue and then creating a pull request. As an open source contributor, you are done with your role. The code maintainer can now go into this pull request, review it, make some changes. They can leave a comment here, maybe you should fix this or add this. They can review the files that have been changed here, and then they can choose to merge it, which is awesome. So yeah, it can be that simple. So that's great. We're going to, one more thing I forgot to mention, but when you're working on an issue, it can be good to, I should have done this before I made the PR, but say, you know what, I'm gonna try this issue. This is just a good practice because if there's a bunch of people who wanna try an issue, you don't all wanna be doing the same thing. And it also lets the people who maintain the code know that someone's working on it, that they might have someone to pair program with, or it's basically just good communication. Awesome. So now we have successfully done and solved a pizza crisis. We're gonna look at a few projects that Embark has to offer. So I'm just gonna discuss very briefly a few Embark projects. We maintain a lot, but I'm gonna go over something called texture synthesis, one called Rust GPU, and PhysX RS. But as I said, there are so many we won't cover today. These are all in Rust, all repos that we maintain. So, if these don't fit the bill for you, check out some others. There's so much there. I have no idea what all these are, but there's just so much. Great. So the first one, this is one of my favorites that we maintain, is something called texture synthesis. So texture synthesis is a lightweight Rust API for example-based image generation. And if that is confusing to you, it was to me as well. So what it really means is it's combining pictures to make new pictures. 2 + 2 = 4. So you can try it yourself. All you need to do is create a new Rust project in your favorite IDE, Visual Studio or otherwise. Then you can add texture synthesis as a dependency. So if you've coded with Rust before, you just go to crates.io, look up texture synthesis, and then add it to your project. And then you can pop in your own images and combine them into cool new compositions right in the command line. So if you look over to the right, this is what's going on. You use these 3 images. You put in the code that we have sample code on the GitHub for texture synthesis. You put in that code, put these 3 images in a folder, run a little script on the command line, and you've generated a whole new image. And this produces some really crazy results. So I recommend doing this on your own pictures and showing your friends. And okay, if you did that and you're like, this is awesome, I want to do more, you can become a contributor. Because that's what I'm talking about today. It's like, if you love a software or you think it's really cool, but you're like, wait, what if we did this? Or I want to try fixing something. Go for it. I'm starting with this repo, but it doesn't have the most issues of the ones we're going to discuss. But this one is open. It has 10 open issues. And feel free to tackle one or create your own. And this is an important point. Remember to create an issue before you work on something. So if you're working on texture synthesis or any open source project, if you're working with the system and you say, you know what, I see this tiny issue, I want to make a PR for it. If it's really, really small and you think it doesn't require a whole issue to explain why you want to fix it, the example being a typo in documentation, just go for it, create a PR. That's why I said typically. But if it is something that's even a little bit bigger, a good practice is just to create an issue, even if it's a really small issue, just outline what's wrong, and then do your PR, even if you've come up with a PR first, because chances are someone might notice something you don't about the issue. They could even point out that it isn't true. So it's really good to make an issue, discuss it a little bit, and then get into coding. It's also great if someone wants to tackle the issue that you don't want to tackle. So you can raise an issue and say, you know what, I don't want to deal with this. Awesome. So that was texture synthesis. Another one I want to cover is physics.rs. So what is physics.rs? It is a wrapper over the physics engine by NVIDIA, which is done in C++, but we are wrapping over it with Rust, which with one of our engineers nicknamed an unholy fusion. He did a whole talk on it that you can watch that I can link to as well. But why should you use this? Well, what's great about this is you can add your own physics engine to your Rust project. And since it's an industry standard, it's feature rich, it's super reliable, and it's really cool because you get to see how we did a C++ wrapper to interact with Rust. So if you're interested in either of those languages, it's really cool how you can see them connect. And this can apply to connecting, any other two languages. And then finally, if you want to just go super simple with it, you can use this to create physics in the command line. So you can see on the right, it's a tiny ball jumping all over the command line. So there's a lot of things you can do with physics. Finally, the last little project I'm going to cover today is called Rust GPU. This is our recently announced project. It's really big, really popular right now, and we're really excited about it. So why is it cool? Well, Rust GPU is basically a project to make Rust a first-party language for GPU code. Those of you who are familiar with GPU code, it's basically, or who are not familiar, shader languages or GPU code is what you do to make things like on the right here. It's how things look and appear in game engines and on your computer. So typically these languages are just GLSL or HLSL, which are very kind of niche languages that you wouldn't get exposure to unless you were explicitly working on shader code. So this has its disadvantages. Like you have to specifically want to create shaders and do shader coding for you to explore these languages. But let's say you're just you're someone who's a hobbyist Rust programmer, and what if you want to make a shader? Well, now you can. So that's what we're working towards. Stuff you can do right now is Rust GPU is in a state where you can already start creating simple shaders using Rust. You can share them, which is something that you can start doing if you don't even want to extend the program. So you can do that right now and share them on our Discord or Twitter or whatever. And if you want to delve deeper, you can solve open issues like implementing loops and switches. It's a very active community, so you can jump into our Discord and already start talking about it. And as I said, it's a big thing right now. So where our texture synthesis was at 10 issues, there's over 70 open issues to tackle with Rust GPU, and it's all happening, every day. Things are always changing. So yeah, as I said, again, it's like frequent discussion on Discord. You can jump in, see what's going on. You can even just jump into the comments going on any open issue, look at a PR. There's just so many different ways to get involved. And getting involved in early stages of a project is a great place to be because there's just so much ability for you to make change and really be impactful with the project. And it's really cool because you get to watch it grow and evolve. Every new release of Rust GPU invents a really cool new feature. And finally, this is just a sample. As I was saying in the beginning, when I had no idea what open source was or what GitHub was, I think what would have made me more interested is just knowing that there was a project that was really aligning with my interests. When I came to Embark, game development was always something I cared about. So now knowing that open source game development was a huge part of what Embark did, that got me super energized about getting involved with open source. So find something that really aligns with your interests. If it's in the Rust ecosystem, crates.io is a great place to start. Even looking on just GitHub for Rust projects. And then of course, if you want to jump into our ecosystem, I'm always here to answer questions about it. And this is our bonus fun fact to end off the presentation. The restaurant that I mentioned in the demo was inspired by a restaurant that does exist, and it's not a coding mistake. This picture is actually from the restaurant where they serve tire pizza, and I'm not sure what this is, but that, and even pumpkin pizza. It's called Pizzeria Bate Popo, and it's in Brazil. Apologies for the pronunciation, but it's a great place, and you should definitely check it out if you're over there. And finally, yeah, this presentation should only be the beginning. If you're new to open source, I hope this is just a first step, a second step, a third step. There are so many cool Rust projects to explore in Embark's ecosystem and beyond, and any other language. There's just so much stuff on GitHub. So yeah, thank you so much for listening. And I'm going to link to both this project and Embark Studios GitHub account, as well as our Discord, if you want to start talking about Rust GPU or any of our other projects. But yeah, thanks so much.
Thank you so much, Celia, for your very interesting presentation. When we started working on the Rust, we were really blown away by the community. Community is such an important part and success factor of Rust. And therefore, it was great that you suggested exactly that topic, because there can't be enough people knowing about how open source works, how GitHub works, how to give something back, how to contribute on such projects. So thank you very much at that point. We have one question, and I would like to add one on top of this one. We had one question about the differences between branches and pull requests. I think it was a little bit answered already in the Discord chat, but maybe you want to give your 2 cents on this issue too. And my follow-up question would be, imagine you said we should do small pull requests, multiple small pull requests for multiple things. Could branches help if I want to add multiple things to a single repository, or can I make multiple forks, or how should I tackle that?
Right. Yeah. Sure. I can. I don't have my screen open. Maybe I'll just share it one more time. So if I go back to here, so the difference between a branch, it can be kind of complex, but it's kind of complex because basically when you create your own fork, you can think of that as a branch of the main repository. The difference is that if you are working in a collaborative environment where you have write privileges, or where you can directly write to the thing, you can create branches on that thing already. But since I'm not PizzaFan, and PizzaFan didn't give me privileges to write to this, I can't just create a branch directly on restaurant.rs. But branches are really great. And if I'm working on my own project or a project with others where I have privileges to that repo, I can create multiple branches that each have a name, like, okay, this is going to resolve pizza issues, this is going to resolve tire issues, etc. So yeah, branches are a really great way to separate those out. And to your question, yeah, I think creating different branches for different PRs is a really good idea. That's usually what I do at work every day. Each branch can specify, what you're working on, and it's a really easy way to create a distinction between each different set of code.
Thank you for describing that. That definitely helps. I have another question. I work a lot with young people, young coders, even kids and teenagers, and they are fascinated by open source. At least this is what I experience in my everyday work with teenagers. But sometimes they are overwhelmed by the sheer amount of issues and a complexity of some issues. At Embark Studios, do you somehow categorize your issues by beginner friendly or something like this? Or do you have a general recommendation? If I'm new to a project, or even a new Rust coder, how can I find appropriate topics for contributions?
Right, that's a great question, and something I ran into when I was first doing this, and I'm grateful for Embark because I really introduced me to that. That's actually an initiative we're kind of starting right now, is to go into our issues and label them as, you can look for this certain label on GitHub called good first issue, I believe it's called. And you can sort by that. That's a great flag just to see if you're a beginner, like this would be a good place to start. We try to make, as the principles that I described before with PRs, like making it as clear as possible so someone can maybe figure out if this would be an easier issue for them, and even describing like, oh, this is a simple issue, or this is a more intense issue. So we try to do that with our wording, but we're starting right now to add more tags to make it more explicit.
That's a great thing. I think that makes it easier for new contributors to get started. What I also found interesting or helpful in my own work is to participate in some challenges. Like, are you familiar with the Hacktoberfest and works like that? I really love them because you can make your own personal challenge. Let's contribute a little bit of code every day in October or something like this. And yeah, it helps you overcome some timing issues and things like that.
Yeah.
It was very helpful. Do you have any strategies on your side where you say, okay, how can I find enough time or motivation, even in a busy month or busy week, to do a little bit of work in this area?
Right. Yeah. I mean, I totally get that. I think managing time is a huge problem for everyone, especially right now. But I think what I mentioned before about finding a project that aligns with your interests just makes it so much easier. Because I know for me, if I don't want to work on something, and I don't need to work on it, it's not going to happen. But if I do want to work on something, I'm going to find the time. So I think if you can find a little project, like there are some Rust projects that are game engines that we sponsor actually. I think Amethyst is one of them. There's a lot of them in there, but I always found those super cool, and I just started like digging in and looking at different issues. So I think if it's something that you find yourself wanting to do while you're doing work you have to do, that's a good place to start because you'll want to keep coming back.
Oh, that's a very good tip. Yeah, thank you for that, Celia. I would like to ask you, maybe you would like to join our Discord server and share some of the GitHub repos that you mentioned, or where you say you sponsor them and they are good places to contribute or to start. That would be really awesome.
For
And
sure.
I also saw that people are clapping, so your talk was really awesome. Thank you very much. It fitted exactly what we do here at Rust Linz
Awesome.
Meetup. And yeah, in the name of everybody who watched this video and will watch the video on the Rust YouTube channel, thank you very much for being here.
Thanks so much for having me.
Thank you. Thank you. With that, I would like to ask Will on the stage. Will, I already saw your video image, and now I ask you to unmute yourself. Will, can you hear me?
I can. How are you today?
We are fine. Thank you very much for being here. I would like to ask you at the beginning the same question that I asked Celia. Where are you broadcasting from? Where are you located at?
I am live from Cincinnati, Ohio in the United States. So
Oh.
I beat Celia in terms of distance from.
Okay, so it's also morning around, something like this?
It is. It's roughly morning. Yeah. For me especially, it's morning, but it's just a little afternoon here.
Okay, very good. So thank you for joining us here at the Rust Linz Meetup. Especially in these times, it's so important to have the community. And on the one hand side, unfortunately, we cannot meet in person, but on the other hand side, we are happy to have you, because if this would be an in-person meetup, you will probably not come to Linz.
But in this
right.
Way, it would be,
you can at least,
but it would be very difficult for me to get there.
I can imagine that. So thank you for being here. You will tell us a little bit about a performance-related talk about Rust. And with that, I would like to open the stage for you. We are looking for your talk, and yeah, the stage is yours.
Well, thank you very much. Yeah, I appreciate the offer. And to come speak. I'm very excited to be here. I think this is a very interesting group. I can't remember exactly how I initially found out about the meetup, but I'm pretty sure it was because of a great video that I saw on YouTube, actually, of one of the previous presentations. Either that, or it was a really, really, really cool link on Twitter. But either way, I thought, man, this would be awesome if I were able to present to this group. So I appreciate Rainer for giving me the opportunity to talk today. And we'll just move right into some things here. If you don't mind, I've tried to set it up where I should be able to see everybody's faces on the screen while I'm presenting. But there are, I hope, lots of opportunities for people to ask questions and to answer questions. So if you are interested, please, during the presentation, please unmute your microphone and ask away. I would love to be interrupted at any time. But if you feel uncomfortable doing that, or would prefer to just write your questions in chat, I'm able to monitor the Discord, I think, to a certain extent. So I will try to keep an eye on that.
Will, let me just give you one important tip here. We disabled unmuting in this talk just for security reasons. So if you would like to ask a question to Will, I would ask you to use the Discord server. And if you want, Will, I can relay the questions to you. Or if you see them directly in your environment, that's fine too. So don't wonder why nobody's talking to you. They are simply not, it's simply not possible.
Not possible. Good. Understood. Understood. All right, well, I'm going to start sharing my screen here. I hope that everyone can see that.
Yes, works fine.
Great, great. I'm going to try to take care of something here that Rainer asked me to take care of. Before I do that, before I get started. Okay, I did that. So I think we're okay. All right. So great. Just again, my name is Will Hawkins, and at any point, feel free to reach out to me over email at hawkinsw@gmail.com if you have any questions, or you can find me on Twitter at hawkinsw. So today I'm going to talk a little bit about the speed limits of loops in Rust. And I hope if I've done my Googling correctly, you will recognize that that should be a local speed limit sign. They look very different from the ones in the United States. So I hope that I got it right. But we'll talk a little bit about, oh, good. I'm glad it is. So we'll talk a little bit about speed limits and how fast we can go with looping. So first, we're going to talk about a little motivation for writing loops in Rust. Obviously, nobody needs to be told why loops are important for any programming language, but a little bit about this context. Then we'll talk a little bit about writing canonical loops in Rust, or what the Rust book would recommend that you write. Then we'll talk about writing fast loops in Rust, which indicates that there might be a problem with canonical loops. We'll draw some tentative conclusions. We'll talk about release mode, which is something you have to always be aware of. We'll address any persistent speed differences, and we'll draw some final conclusions. So I hope we'll be able to address any questions as well as we go. So here we go. So the motivation for this talk, I started with trying to benchmark a simple function call. I was trying to answer the question of whether it is faster or slower to call a function with move semantics than it is to call it with sharing semantics, passing a reference versus passing something that's movable and just giving up control of it to the function. I would anticipate, but I don't want to presume that everyone understands the difference, but it's not, I'm happy to answer that, but it's incidental to what we're talking about here. So you don't have to understand the difference. The point is that my motivation was to time a certain sequence of operations. Benchmarking is obviously a very difficult thing to do correctly, but as a rough approximation, to benchmark something, what we can do is ask the system that we're running on what the time is before we do some operation. We can do the sequence of operation a certain number of times. We can get the time after the operation is complete, after the sequence of operations is complete. And then we can divide the difference between after and before by the number of times that we did the operation to get the average time to complete a certain sequence of operations. So we're going to do the repetition here, this X times, in order to get an average. Because if you do it once or you do it twice, you never know what system level artifacts might appear, and you might get a little bit of an artifact. Hope that makes sense to everybody. So just in pseudocode, what that might look like is we have a function main, which is where we're going to start our program. We're going to name a variable before. We're going to get the system time using our hypothetical now function. We're going to repeat X number of times this certain series, certain sequence of operations. And then after that, we're going to ask for the system time again. Then we'll calculate the average for the time that those executions took by subtracting before from after. And then we'll divide by X, which is our total number of iterations. And we will print out the average execution time. Hope that makes sense so far. I'll pause a few seconds here to just see if there's any questions that come into the chat before we go any further. All right, got a big old thumbs up there. So I would like to ask a question now for the chat. In Rust, what is the quote unquote right way to write a loop to repeat operations a fixed number of times? There's a couple of different ways to do it, but I'm curious to see what people think is the way that the book recommends. Oh, somebody read my mind. Good. These are good answers. Yes. Great, Mega. Very good. All right, great. So just for those of you following along at home, ooh, I like Not Matthias's answer. That's really good. I like that. But let's go with Rainer and Abik. I hope I'm pronouncing that correctly. Their answers here. And we'll talk about iterators. So in an iterator, what I would do is I would write a canonical loop with a for. And I would say for something in some iterative range. So let's look at our first coding example here, and let's turn what our pseudocode into some real code. I hope that that's big enough for everyone to see. If it's not, prior to the presentation, I sent out a link to the GitHub repository so that you can follow along. And this is the benchmark-iter.rs file. What you can see on line 7 is that we've got this function main, which is just like in our pseudocode. We're going to define X here to be some relatively large number of iterations. We're going to take the system time before the operation. And now in lines 12 through 14, this is where we get down to business. And we will see the recommendations here that Rainer and Abik made, that this is the kind of loop, the canonical kind of loop that the Rust book recommends that we write. Just to explain this a little bit more, what this is saying is that we've got for some variable that we don't really care about its value. So we're going to leave it as an underscore, which is an indication in Rust that we don't care about its value. And we're going to say in, and now we've got this interesting syntax here, 0.x. 0.x is an implicit way to turn a range between two numbers into an iterator. At each version, at each iteration of the loop, or each pass through the loop, Rust will ask this iterator for its next value and assign that to this underscore variable. Again, we're not using the underscore variable directly. We're just using this as a way to do this particular function, to execute some function to time here, X number of times. Once we've done it X number of times, we take the system time again, and we calculate what I call the average, but is not really the average. This is just the time, the total time that takes in seconds. And this is okay for right now. when we would go back, what we want to do is actually calculate the average. But this is enough to generate to show the point. So let's actually run this. I'm going to open my terminal here. Oh, nuts. All right. That moved it to a different window, but I want to bring it back over here. All I'm doing here is making sure that I have the right version of the code linked as main.rs so that when I build the code, Cargo will know what to build correctly. Oh, got the wrong one. Sorry about that, everyone. All right. So let's do cargo build. Good. And let's see how long our loop takes here with cargo run. This is not good. It's taken a long time to run. But let's give it a second and see if it finishes. While we wait for that to finish, let's see if there's questions coming in.
There is one question. Maybe you can repeat it for people who don't join Discord. Does the blanking, the iterating variable, speed up the loop, or does it only help linting or compiling?
We'll get into that in a little bit later. But the question again, Rainer repeated it, but I'll repeat it again. Does blanking the iterator help speed up the loop, or does it only help linting? And that's not a question that I addressed directly, but we'll actually see when we go through here what's going on. And my guess is that it really only helps with linting. So just a very, very, very good question. So I have, I see a comment here from Not Matthias that talks about how LLVM can optimize the loop. And also we've got some good comments coming in from Stable Miner as well. And I don't want them to ruin the surprise. So, so if you're interested in knowing the answer before we get there, you can read some comments in the Discord channel, but otherwise follow along with me. So unfortunately, the time between those two times that we took was a full 22 seconds. And again, this function that we're timing isn't really doing anything valuable. So that seems like an awfully long time to take for just doing nothing over and over again. So that was slower than it needed to be, right? Probably way slower. So let's take a look at what's actually going on under the hood. One of the ways that you can look at what's going on underneath the hood is by doing something called objdump. An objdump will actually be used to take the binary that the Rust compiler generates, Rust C, and actually look at the machine code that's generated, which gets executed on your system. And I find this to be very, very, very interesting. And I love looking at object code. It's not something that everyone likes to do. And it's also not something, it's also relatively intimidating for people, but it doesn't need to be. It's actually very straightforward usually. So what I'm going to do is I've annotated some of the object code files that are generated by the compiler for these examples. just to give us a sense of what's going on. So let's take a look at those right now. All right. So what we're looking at here, let me know if this is big enough, but what we're looking at here is the machine code that the compiler generated for this loop, for this main function. And I've highlighted some really interesting parts of the code. The first thing that we're going to do is create some space for the local variables. We're going to initialize that X value. We're going to call system time now and store it in the result before. We're going to make the 0 iterator the big iterator. And then we're going to start the loop. So we have the top of the loop and the bottom of the loop. So this is the entirety of our loop right here. And after that, we're going to take the second of our system times and record that. And then down here, what we're going to do is we're going to print the results. Now, what's very interesting about this, you can all go back and look at this on your own at any time with the comments, and feel free to do so. But what I find really interesting and noteworthy, which may be the cause of our slowdown, is that at the top of the loop, each time we're calling this function. Function calls are not cheap, and each iteration, we are calling this next function in order to get the next value of our variable. Very expensive, and ultimately the source of the problem. So this is a big deal. So here is why that loop took so much time. Let's see if we can do better. So that's a problem for us because the Rust book recommends that we write these 4 in loops with iterators as the canonical and readable way to do that. So the community would not recommend doing something that is slow. And the simple case is such a simple case that we have here. The for in loop should be as fast as a while loop. So let's actually do the comparison and see if that's the case. So what I'm going to do is I'm going to rewrite this benchmarking function with a simple while loop, which is not the recommended way to write loops in Rust, but it's definitely a way to do it. So I've already got that file written here. It's called benchmark-while.rs. And what you'll see is that the setup and operations before the loop are just as the same as they were before. We're doing the same number of iterations. We've got, and we're taking the before time. The only difference is that we do have to take care of making sure that we execute only the right number of times. So we create our own variable here, our counter variable I. It's immutable, so we can change it. Starts at 0. We calculate that we're going to do the body of this loop while that value is less than our upper limit. We'll add 1 every time. And we'll say, call some function to time. Again, after the loop, everything is the same as it was before. No difference at all. Interesting. Okay, so now that we understand that, let's go back and see how long this actually takes to run. Again, I'm going to make sure that Cargo knows that I'm executing the right file here. going to do a cargo clean to remove everything that we had before. And I'm going to do a cargo build. Great. So now we have a new version of it that's using the while loop. And I will run cargo run. Wow, that is significantly faster than the one before it. This time it only took 2 seconds to do all those iterations instead of the 22 seconds that it took before. That is a significant difference. So what is coming to mind is that there's something that's not right here, something not right. So again, let's look at the code that the compiler is generating and see what's going on. Again, I've annotated that code and I've placed it in this repository that you can all see. But let's open it up here. We'll go through this quickly. We make some room for the local variables. We store the result from system time as before. And we're again at the top of the loop. What you'll notice here is that at the top of the loop, there are no more function calls. There is no function call here to get the next value of the loop. That's because everything is taken care of without calling it, without calling a function. The incremented iterator, or the next value, is calculated with straight machine operations. These are simple adds. Remember, we were adding 1 every time we go through the loop. So we add 1 every time through the loop. That does not require a function call. And what you'll see is in the loop body, the only function call that we're doing now is to the function that we're timing. So this is the cause of the significant increase in speed. We don't have to call a function to get the next value of the loop every time. We simply add 1 to the value, which you can see we're doing right here. We're adding 1 to the value of I, and then we're jumping back to the top of the loop. If that value is still less than our upper limit, we do the loop again. So we've got our conclusions, the end of the presentation. While loops must be faster than for in loops in Rust. Does anyone disagree with that statement at all? I know that there are probably at least a few people who have spotted this, but I'll wait for some answers. All right, Stable Miner fully disagrees, and I think I know why. Felix disagrees, good. All right, good. So this is not a fact. Tell me, there you go. All right, now we're getting some good answers. I like this. Peter and Stable Miner and Felix, I believe, have already sort of thought this through. What am I missing here? What am I missing about what I've just shown you that might make this behavior different? Exactly. All right. So simple optimization here. What we're doing with these cargo build operations before is what you'll see, basically the compiler is telling us, this is an unoptimized build. This is unoptimized. And it also includes debugging information, which is helpful for finding problems in Rust code, but it's also not useful for trying to get the most speed out of the compiler. So let's do this. Let's make sure that we're doing our cleanest build, and let's go back to the iterator version of the code. Now, if I execute cargo build again, I'm going to get the debug version one more time. So what I need to do to get Cargo to build a optimized version is to execute in release mode. In order to do that, I just pass the -- release flag, and away I go. What you'll see is that the finished line here indicates that we built a release version and that it is indeed optimized. What's really cool is that didn't take any longer to do than the unoptimized version. However, if we try to debug an optimized version of the code, it's going to be a little bit more difficult. Now, we can't do cargo run to execute an optimized version. We have to actually call the binary that was generated directly, the program that was generated directly. So we'll do target, release, and we'll do, come on. So this will let us execute the optimized version of the code that we compiled. Oh boy, 0 time between. That's really fast. So that was our big problem. We weren't optimizing the loop before. And once the compiler had its way with our loop, the time between went to 0. So now let's also compare that to how the optimized version runs, the optimized version of the while loop runs. We'll do cargo build, cargo clean, I'm sorry. To get rid of the old version, go back here. And I can't read quickly enough in the chat, but someone gave me a really cool answer to the question that I've wanted to know for quite some time, and I'm going to tell you in just a second what that is. We'll do cargo clean again just to make sure. Cargo build, release. And now what I never knew was this. You can do cargo run -- release, and you get the exact same thing as running the binary or running the program directly. Very cool. So there you go. The answer is the while loop now takes just as long as the iterative loop, which is great. So let's go back and draw some more conclusions. That was a close call, people. That was a really close call. We almost discovered a situation where the Rust book recommended doing something in a canonical, very readable fashion that was much slower than the way we could do that. But we got away from that. That situation is not true because while loops and for loops take exactly the same amount of time. That is a big, big win. I'm going to pause here because I think you might be waiting for the other shoe to drop. I've labeled this a fact, but is this actually a fact? Or is there something else that we perhaps need to investigate here? I see some people typing, which is good indication that there are some thoughts coming. I'm excited about this. Yes. Yes. Felix, good. Show the obj dump. Yes. Good. Rainer is exactly right. Felix is on the right track. I like this. Okay. So let's look at the obj dump of what's going on here and we'll see what happens. Suspicious. This is very suspicious. What we notice here upon complete investigation is that the optimizer has done far, far, far too good a job. And what happened is that the function and loop in its entirety was taken away by the compiler. The compiler realized that that loop meant absolutely nothing to the outcome of our program, and therefore it was entirely optimized away. What you'll see here is that the code is now only calling system time twice back to back. And what we would expect to see in between is some operations here for our loop, but there aren't any. In other words, that loop is gone entirely from this code. So this is not a good way to evaluate speed for a loop because, well, we didn't do any loops at all. So we have to go back here and we have to label this a tentative fact. We're not really sure that that for in loops and while loops take the same amount of time, but we're going to investigate whether this is actually the case. I like a couple of answers here that I see in the Discord chat. Benchmarking is hard. Yes. Oh, it's almost like Abik has read my mind here on what's going on. I like the comment, no code is actually the safest code. That's exactly right. I work in safety and dependability. And my boss used to say that the safest airplane is a rock because it never goes off the ground. So no code is the safest code. Yes. Rambua, I can't pronounce, I'm sorry, your screen name. I like that comment a lot. Abik, I like your comment too. And that's exactly what we're going to do. So the takeaways from release mode and what we just saw is that the optimizer does too good of a job in optimizing our code and doesn't give us an accurate way to benchmark. So what we need to do instead is to use something called volatile variables. Volatile variables, when we label them such, when we label a variable volatile, it tells the compiler, don't optimize away the operations that are done on this variable because they matter. This name volatile comes from back in the C language where you used to be able to just say volatile and then the name of a variable. And what programmers use volatile for is to make sure that the operations are actually done into memory rather than optimized away. This is important for any software that needs to directly interact with hardware by writing registers, by writing register values that the hardware might use. So what we can do is, thanks, Rainer. I appreciate that. I won't take it personally that I don't have the qualifications to pronounce that user's screen name correctly. I have to be Austrian, which I'm definitely not, so I apologize for that. But back to the task at hand. Abik was exactly right that what we can do is we can use the volatile crate in Rust in order to accomplish the same thing that we could have done in C. So let's see what that looks like. I've got this version here that I've rewritten, and I will let you browse this on your own later. But what you'll see is that nothing major has changed. We're doing two loops back to back instead of having them in two separate files, but we're going to do the operation the same number of times. We've got some mutable value here that we're going to increment each time through the loop to make sure that the loop body is actually done. And in each loop, what you'll see is, just to make sure we're comparing apples to apples here, on line 24 and on line 13, we are iterating a counter variable because we need to iterate a counter variable down here. We want to make this commensurate and do a counter variable up here too. We're going to, at each iteration of the loop, we're going to write back this volatile value, which is our indication to the compiler not to optimize the way. We're going to do that in 12 and line 23, which is exactly the same operation. Again, apples to apples. And now we're operating at a little bit of a different time scale here. And so we're going to get things that take microseconds rather than seconds. So we're going to call duration since, but we're going to convert it to microseconds instead of seconds this time. So we'll see something that's a little bit different. And what we'll do at the end is we will print out the two different times and see if they compare. So let's execute that and see what happens. Again, just to be sure, what we're going to do is we're going to run this in release mode to make sure that we get the best out of the compiler, but not too much. That was quick because I didn't clean it first. All right, that's much better. So let's do cargo. I learned another thing. I can do R, save myself some keystrokes here. All right, so now in microseconds, it looks like they both take roughly the same amount of time. Perfect. Now let's do this a little bit more. We're not really satisfied that one answer is enough to prove that we are correct. So let's do another couple of iterations. And in order to do that, I've set up a little script that will run this a few times and make a CSV file that we can use to actually plot the results. So we're going to do that 15 times and record the answers in a file. And then we'll quickly graph that on screen just so that we can see the results. In the meantime, feel free to pop in any questions that you might have in the chat. All right, no questions. Either I'm doing an interesting job here and presenting you things that you're thinking about and chewing on, or else I've completely lost you and I feel like an idiot. So either way, I hope it's the former and not the latter. So let's use LibreOffice here to open this file and see what we get. I'm going to quickly grab this, make a little graph here, make it a line chart, put some lines on it, and we'll see what we get. All right. Pretty impressive stuff there. So what we see is that most of the time spent in the two loops is roughly equivalent. We've done 15 iterations, and we see that they pretty well track each other. One is not necessarily always faster than the other. Interesting. So I hope that is enough evidence for you to believe that these two iterations, these two types of loops take roughly the same amount of time. Now, let's go back into the object code and make sure that we're not being fooled by the compiler again. And I think what you'll see here is, I think you will see something very interesting and something that will make you very happy. What we see is the first body of the loop, the iterator body, looks like this. It looks like we're doing some sequence of add operations, and then we're going to jump to the top of the loop if we haven't hit our limit yet. This is a technique called loop unrolling, which several of you have referred to already in the chat. So this might be something that you're interested in exploring more if you've never heard of loop unrolling before. I'm not going to go into that right now because I don't want to bore anyone. But in the questions after, I'm happy to explain this. But here's the big surprise, is when I go look at the loop body of the second loop, what you'll see is, oh my gosh, it is exactly the same as the first loop body. So what we've determined is not only that the two loops execute in roughly the same amount of time, it's that the compiler generates identical code for both of them. Identical. That is pretty amazing. I mean, that just blew me away when I saw that. So now we can make some conclusions. We know that in release mode, when properly benchmarked, that the while and the for in loops take the same amount of time. That is pretty cool. So that is the end of the conversation. That is the end of what I have prepared to talk to you about. I just wanted to say thank you to the Creative Commons providers for the fact logo that I got off of the Noun project. So I want to give them credit as appropriate for the Creative Commons by attribution. And now I think Rainer's going to pop in and hope direct some questions to me. But I hope that you all enjoyed the presentation, and I hope that you will give feedback if you didn't and think I can improve. I would always love to do better.
Thank you very much, Will. It was very interesting, and there were a lot of discussions going on in Discord. So definitely you are not alone. People were following closely. And yeah, I personally learned a lot. I've not taken so much time taking a look at obj files. So it was very interesting for me. We have some quick questions about that. And one of them, I can remember my own. You added the I+1 statement in the for loop. I think just to make them comparable, couldn't we remove this I+1 and make the for loop even faster than the while loop? I think this was one question.
Yes. So what is interesting about that is actually, if you look at the object dump, if you look at that, what actually happens is that that never really gets executed at all. So when it actually gets optimized out. So you'll see up here that this is the version of the, let me just go to the while version down here just to prove this to you. But that iterator value, that operation with that I+1 that we imposed in there to make them commensurate actually doesn't even show up in the object code, in the machine code that the compiler generates. So it might have in fact been unnecessary. Unfortunately, in the second loop, it is necessary because we are using it as our iterator value to make sure that we are limited properly. I suppose that what several people are saying, and Rainer, maybe what you're asking is really, couldn't we just use that mutable variable to do the exact same thing? Because we're already incrementing it by 1 every time. And I think that's exactly right. So really what you're saying is something like this. Let me go back to the code. What you're really saying is something like, is that right? Is that what you were getting at?
I wasn't exactly thinking about that, but I get what you mean. Yeah.
Okay. Yeah. I think we could do that if we wanted to take out the I iterator. But yes, in general, the fewer operations you do in a loop, the better.
Okay, thank you very much. We had another question. Maybe you have an opinion about that, or maybe you have some experience. I don't know. Felix, I think, brought up the crate criterion, which is a crate for doing micro benchmarking. Have you ever tried it? What is your opinion about it?
No, this is great. This is brand new to me. So thank you, Felix, for that information. I'm going to look at that. I have done, unfortunately, very extensive work doing benchmarking. And I know that it is by far not the easiest thing I've ever done. In fact, it is painstaking to get right. So any help that's out there, any standard help, best practices is really beneficial. And so, yeah, I had no idea about the criterion crate, and I'm going to look forward to getting into that. So thank you very much, Felix, for that.
Awesome, thank you. This is what I love about Meetup, isn't it? Because you benefit from each other, you show each other some important libraries and things like that. I really love that.
Absolutely, that's the best part. That's why I think we do this, is so that I can learn. I'm not presenting so that others can learn. This is selfish. I like to learn, and it just so happens that I learned something that maybe other people find interesting. So thank you for the great contributions here.
Absolutely, absolutely. I have seen there were some detailed questions a little bit up there. Let's make it that way. Will, do you find the time, or do you have the time to hang around in Discord a little bit more to get into any questions and answer some questions that are still unanswered?
Absolutely. I see one version here from Zeddy. Let's do this real quick experiment.
Okay, yeah, please.
Okay. So Zeddy asked, what does this look like now that I changed it? So what you'll see here is, again, I removed the I+1 operations here in both of the loops. And Zeddy wants to know if that still is exactly the same when I generate the object code for it. So let's look at that real quick. This is a very interesting question. Oh, interesting. All right, so let's see what this does here. I think that I might need to dereference this and see. Oh, I need to do a read on this. Hang on. Sorry. That should do the trick. Good. We don't really care about the warnings. We'll deal with those later. So let's do, so in order to do that, we're going to do objdump demangle, which makes the symbols in an object file much easier to read. We'll say -d to do the disassembly. And we'll say that we are in target release Rust Linz, and we're going to redirect that output to temp.obj. Temp.obj main. All right, so here's our main again. So our iterator version looks like this. Same as it was before. And let's jump down here a little ways to see what the second version looks like. Oh, interesting. Hold on. This is confusing to me. I don't see a second version. Interesting. So I think this is something I'm going to have to look at a little bit more. I'm not exactly sure what's going on here, to be honest with you. Yeah, this is an interesting question. All right. Well, what you should do then, if you don't mind, Zeddy, is to actually go ahead and post that question into the GitHub repo for this code as an issue, and I will make another object file, another annotated object file that goes into this, if that's an okay response. Because I'm not exactly sure what we're looking at here, and it'll take me some time to do it, and I don't want to waste everyone's time.
Oh, that's great if you could do that. Definitely.
Absolutely,
So Zeddy,
definitely.
go on. I already posted the GitHub link into the chat. So if you scroll up a little bit, you can find Will's GitHub link and go there and write the issue. And it would be awesome, Will, if you find something out, if you could share your insights.
Absolutely. Yeah. Yeah. And I think we can, we can probably deal with this question pretty quickly, but yeah, I'm not particularly, I'm not particularly excited about showing my ineptitude with doing this Oh, wait. Actually, you know what's interesting about this? Is here it is right here. I see the answer right here. So what we're going to do is, yeah, so we're roughly in this section right here. It looks like it's not unrolling the second loop at all, because instead of unrolling those ads, what we have here is just one ad repeatedly, and then we do a comparison and we do a jump. So this looks like the body of the second loop right here. Yep, that's exactly what it is. So what you'll see is this is the bottom of the loop, and it's going to jump to 5270. And 5270 is this add by one. It's going to store that back into memory, and it's going to compare. It's going to do the jump back to 5270, yada, yada, yada. It's going to go on and on and on. So what you'll see is now the iterator loop is actually going to be faster because it was able to be unrolled. The while loop will be slower because it was not unrolled. So I hope
an interesting finding.
Yep. So I hope that answers your question.
So you just started the assembler in your mind and you quickly took a look at the assembler code. Kudos for that.
Well,
just doing live assembler debugging here. Awesome. Really awesome.
Yeah, this is not something that this is information that I like to say I wish I didn't have. So I wish I didn't know how to do this, but I've unfortunately spent far too much time doing this. So I hope that answers the question.
I think so. I think so. Yes, I think so. Matthias has a comment on that, but I don't know if you want to go into it because you used the volatile variable. Maybe it wasn't optimized because of that.
Yeah, that's an interesting question. I'm not sure. I honestly probably couldn't suffice it to say to pass a guess here. It'd be completely uninformed. So.
Okay, I think if you stay a little bit longer in Discord, you will have some interesting discussions with some people because you have definitely touched a very interesting topic that many people are interested in, performance optimizations. If you are a Rust developer, definitely you are interested in performance, aren't you?
Yes, yes. I mean, I know I personally am very interested in performance, but I get the sense that a lot of Rust developers are in general interested in performance. That's why that besides safety, they like the high level language being able to compile down as closely as possible to the low level details.
Awesome.
Out of it.
Awesome. Will, thank you again for taking the time, for preparing this great talk, inspiring such intense discussions. We really love that. Yeah, we loved to have you as a speaker. We will definitely try to cut the video as soon as possible. And as always, we will publish the videos on the Rust channel, and we will all let you know through Discord and Twitter. So make sure to follow the Rust Linz Twitter account, and there we will publish some news about first, our next meetup, which will be, of course, in March. We haven't fixed the speakers yet. So if anybody here in the audience has an interesting topic and you would like to speak, just like Will did today, for instance, please let us know. Use the Session Ice button on our website to propose a session. We would love to have you here. And with that, I would say again, thank you so much for our speakers, for both of them, for today's talks. We really enjoyed having you, and we want to say thank you for everybody who was watching us either through Zoom or through YouTube. And with that,
thank you again. Thank you again for having me. I really, really, really appreciate it. It was great to be here. So thank you.
Absolutely. It was a pleasure. With that, I would like to close today's meetup, and I would say goodbye and see you all in March. Bye.